Okay, so we're looking to find the intersection between a line and a plane. So it is a form of simultaneous equations, but I've just scribbled out the simultaneous here because I think that might lead you down the wrong path. But you are, to find the point where a line intersects with a plane, you're forming an equation and you're solving that for the parameter lambda. And that parameter lambda is really the parameter that tells you whereabouts on your line you are. So, you put your line in parametric form, you substitute into the equation of the plane, that's where the simultaneous equation bit actually happens, and then you solve for lambda. So, here we've got a plane pi and a line L. So we need to give ourselves our parameter. We're going to want those, we're going to want the parametric equations for the coordinates. So we arrange those. X minus 11 over 4 equals lambda, so x minus 11 equals 4 lambda, so x equals 4 lambda plus 11. And y equals 5 lambda plus 15. Z equals 2 lambda plus 12. So now we've got that line in parametric form. We've got an equation for the plane with x, y and z in it, so we can just substitute in these values. So x plus y minus z equals 0 can become 4 lambda plus 11, that's the x, plus 5 lambda plus 15 minus 2 lambda plus 12 equals 0. And if you sort all of that up, you end up with 7 lambda plus 14 equals 0. Which means that lambda equals minus 2. So we've worked out that lambda equals minus 2, and then you just need to go into your parametric equation, substitute in for lambda. So x equals 4 times minus 2 plus 11, which gives you 3. You can work out y, you can work out z using these equations, and that gives you the point of intersection. Now please make sure that you write the point of intersection as a coordinate with brackets. Don't write it as a vector, you won't get the marks if you write it as a vector. So write it as a coordinate in brackets, and you can check at the end, and I would, that your coordinates for x, y and z work in the plane. So you got your plane equation pi x plus y minus z equals 0, so if we put in the 3 plus 5 minus 8, you work that out, it does give you 0, so we're happy. Okay, now I think I've already taught you the angle between a line and a plane, but I'm not 100% sure, so we're going to do it again. So if you've got plane pi, this is supposed to be a plane, but we're looking at it from the side, so it looks like a line. And we've got the normal to the plane here, which you can get very easily from the plane equation. Remember, it's just the coefficients of the x, y and z. And you've got the line. You can get the direction vector of the line very easily. And if you find the angle between the line and the normal to the plane, the thing at right angles to the plane, that's just going to be 90 minus the angle you're looking for, or pi by 2 minus the angle you're looking for, depending on whether you're working in radians or degrees. And then you can find the angle you're looking for. So that's what we're going to do. So we're looking to find the normal vector, we're looking to find the direction vector of the line, and then we're looking to use the dot product technique from higher to find the angle between those two vectors, and then we're looking to find pi by 2 minus that, or 90 minus that, to give us the angle between the line and the plane. Okay, so the normal vector of the plane, very simple, just the coefficients, 5, minus 7, 2. So the magnitude of that is going to be the square root of those things squared. Oops. 5 squared plus minus 7 squared plus 2 squared. And that comes out as 78, yeah. So that's root 78. Right, the direction vector of the line. You can just go along and say, well, what's the number on the bottom? I mean, obviously there aren't any numbers on the bottom here, but if there were, it would be minus 1, and then there's a 3 there. It fits better into my brain if I actually turn the line into vector form first. So r equals so you get the parametric form. And then you get r equals, and we're just looking at the point plus lambda times the direction vector. So here the x coordinate of the point is 0, y coordinate is minus 4, z coordinate is 15, and the direction vector minus 1 times lambda, minus 1 times lambda, 3 times lambda. But you could have got that directly from there if you wanted, but this is your direction vector. And the magnitude of d is just the square root of minus 1 squared plus minus 1 squared plus 3 squared, which equals root 11. So your dot product, your scalar product, is n dot d, which equals 5 times minus 1 plus 7 times minus 1 plus 2 times 3, which equals 8. So magnitude of n times the magnitude of d times the cos of the angle between them, which is 90 minus theta, remember, equals 8. And we can put those numbers in, so we can rearrange this. So cos of 90 minus theta equals 8 over these magnitudes multiplied together, so root 78 times root 11, and that gives you that 90 minus theta is cos to the minus 1 of this thing. Looks a bit prettier if we multiply those together. And that gives us 90 minus theta equals 74.2 degrees, which means that theta equals 15.8 degrees. Now, remember that if you're doing stuff in radians, then instead of using 90, you'd be using pi by 2 on the way through. And if the question gives things in radians, you should be answering radians. If the question gives things in degrees, you should be answering degrees. If the question doesn't give things in either, you can answer in whichever you want.